All right, so we're going to quickly, we learned about Coulombs law last class. So we've talked a little bit about how electric charges in space can actually create a force due to the electrostatic force. We did a few problems that involved Coulombs law, which we know is equal to Ke Q1 Q2 over R squared. And remember, the Q1 and the Q2 are in absolute value, so if they're negative, you make them positive. But we're going to encounter a different type of problem today, and that problem is the type of problem where we actually have, where we actually have three charges in space together, okay? So what we learned when we learned about this is we learned, well, if there's two charges, there's an electric force that exists between them. I'm going to call this the force of 2 on 1. Now, there is also the force of 1 on 2, right? Because they're equal and opposite forces. We know Newton's third law. For every action, there's an equal and opposite reaction. There has to be a second force, okay? But what do we do in a situation when there's multiple forces, which you guys have encountered when we did forces in general, right? What if there's more than one force? Yes?
Like do the direction?
Yeah. So essentially, you're right. You do the direction. Essentially, what it says is we know that if there were three charges in space, one has a charge of 2 positive, one has a charge of 3 negative, one has a charge of 1 positive. Now, if we look at this, if we wanted, and they'll always say, what is the net force acting on charge 1, or charge 2, or charge 3, right? Or they'll tell you there's no net force acting on it, which means that F net equals 0. Okay, good. So if we look at this, we've got a situation where we've got 2 positive, 3 negative, and 1 positive. What is this guy going to do to our point charge is what we call it. What is this guy going to do to that guy? Is he going to pull him toward him or push him away?
Towards.
He's going to pull it toward him. So we know that the force of 2 on 1 is going to be to the right? Now we look at this guy. What's he going to do to this guy? Right or left?
Right.
He's going to push it. This guy is going to be pushed that way by this charge, right? So if in the end, this is the force of 2 on 1 is acting to the right, and this is the force of 3 on 1 acting to the left. Yes?
That has to do with the positive and negative on the charges?
Absolutely, yeah. Because the reason why this one's pulling him is because they're opposite charges, so he's going to attract it. And this one is the same charge as that one, so it's going to repel it, okay? And so what we've got is we've got two forces acting on. Now, do those forces go in the same direction, or do they go opposite directions? Opposite. So what do we do when we write an F net equation when they go opposite directions? Subtraction, right? So essentially, we could write an F net equation for charge 1, and we could say F net, well, they did it. We would say that the F net would actually be, let's do this. F net would be equal to, help me out, it would be F 2-1. Everybody following me, yeah? F 2-1 minus F 3-1. Are you following me? So there's an F net equation that could be, now, the reason why I did F 2-1 is positive because it's to the right. And then the reason why I made F 3-1 negative is because it's the opposite direction to the left. Yes?
What does the 1 stand for at the end of it?
So that's a great question. This is and there's various ways of doing this, but this is how I do it. I always say this is the force of 2 on 1. Are you following me? And this is the force of 3 on 1. Okay? Yes?
I can understand why 3 on 1 is going this way. If you're going between 3 and 1, aren't they both positive charges? So they go like...
They repel each other, yes. So this one would push that one away. Okay? Now you're thinking of both of them acting, but we're just focused on one charge. That's the hard part. Like, I could also do a free body diagram for this one, and it would be F 2-1 that way. You with me? And it would be F 1-3. It'd be F 1-3 that way, right? Right? It would be F 2-3 that way. Yes. So I am failing miserably over here. Okay, let's try that again. All right, so we've got an F-net equation we can work with. Now, from there, all I really got to do is figure out what is the force of 2 on 1. Well, that's where we go back to Coulombs' law, right? We know that force of 2 on 1 is equal to KEQ1 Q2 over R squared. I didn't put the absolute values there, and the only reason why I didn't is because in my head, my whole life I've been doing this, I just make it everything positive. You with me? And that just makes life easier. If you make everything positive, life's easier. So then I put in the charges. Now, look at the charges I put in there. I put 3.2 times 10 to the negative ninth, and I put 4.8 times 10 to the negative ninth. And I see some perplexed faces. Let's look back up here and see what is the charge on 1. 2 positive, yes? Okay, well 2 positive, how did I get from 2 positive to 3.2 times 10 to the negative ninth? Paige said 1.6. Remember, every extra positive charge is 1.6. The Q on that is 1.6 times 10 to the negative ninth coulombs. That also means that if you had 2 positive, the charge would be 3.2 times 10 to the negative ninth coulombs. And if you had 3 positive, it would be 4.8 times 10 to the negative ninth coulombs. Are you following me? Okay? And so this really, this is, we've got a 3 negative. Now, all I would do is I would make that negative because it's negative there. But I know it's in an absolute value, so I just make it positive. Yeah? Okay? So normally I would make this negative, but I'm putting it in an absolute value. So what I've done is, because I know this is 2 positive, I went ahead and put in the 3.2, and I know this is 3 negative, so I went ahead and put in the 4.8. Now I looked at it, and look, they're 3 meters apart, right? So I just put in 3. Remember that value squared, something a lot of people mess up. So from there, all I did is I solve for what the force of 2 on 1 is, right? Step 1, I've got this one here. If I want the net force acting on 1, I've already got that. All I need is that. So that's where we go down and we use the force of 3 on 1. And what are my 2 charges going to be? Positive and positive. Do you know what the numbers are? 3.2 times 10 to the negative ninth and 1.6, right? So I go ahead and do 3.2, 1.6, Coulomb's constant, never changes, 8.99 times 10 to the ninth. I got to go figure out the distance between them. You'll notice this distance is 3 here, and that's 5, so the distance between 3 and 1 is 8. So I went ahead and put in the 8 there, and then I solve for it. And when I solve for it, I ended up with this. From there, it's easy. All I got to do is plug it in to my F-net equation. I've got this was my first answer. This is my second answer. And when I do the math, I get the net force acting on charge 1. Okay? So that's a 3-charge system where you have one charge acting on other ones. Okay? So let's walk through one together. And then after we walk through one together, you guys can try one of the we-dos on your own. Copy? All right, so let's do this. Maybe I got another one in here. Oh, no, not going to do that. Okay.